promise you only 7 minutes of boredom. So basically, this thing's a blow molder. Anybody ever used one of these, like in high school or tech school a very long time ago? Nobody? Really? Yes? 1, 2, maybe?
I just used one tonight.
Oh, good job.
And I failed.
So what this thing does is there's a barrel up top here. Usually there's a nice little cover that goes over the top of it. And essentially what's happening is there's a big pneumatic cylinder here, and the air noise that you're hearing, that's the safety. So that won't allow me to close the cylinder. Actually, I guess I'll leave that closed, it'll be less noxious. So it won't allow me to close the cylinder on my hand if this guard isn't in place. This here is a nice ANSI-approved safety system, maybe. Got a nice hole poked in the middle there, right where you can stick your finger in. So anyways, we just bought this thing last week, and we've been poking around at it, getting up and running. The vice grips are a relatively recent addition this evening, as we were thoroughly testing some things. Thanks, Tim. So what goes on this thing is there's normally a hopper that comes in right here. It's really hot, but there's plastic that falls down. It takes in plastic pellets. I believe this is low-density polyethylene, so LDPE. Tim is going to grab a couple of chunks out of here, maybe. And it comes in pellet form. So this has been extruded by another machine, chopped up these little tiny pellets, and intended for kind of redistribution as pellets to be run into more machines like this. So some giant machine makes little tiny sticks, and then it chops into little tiny chunks to go into more machines to be able to make more things. So what happens here then is there's a band heater up here. This whole machine's all 120 volts. It's intended for like a high school or a college or a grade school shop, not grade school, middle school shop. And essentially there's a heater up here, there's a heater down here, and there's a nozzle that comes out the bottom. The nozzle is annular. What that means is the plastic doesn't come out the center of it, it comes out as a ring. And the ring kind of drops down, and we have 2 molds over here. So this mold here has a wedge in the bottom of it, and there's an identical other half to this. So it's got this wedge down here, and what happens is the plastic falls down through the channel. It just droops down in space. You'll see that happen in a minute, assuming it works well. Which is a variable quality here. We'll find out what happens. We're either going to get a big blob of plastic when we try this, something like this. We made 4 of those tonight. Or we're going to get one of these cute little barrels, and we've made about 12 of those tonight. So the odds are we'll get a barrel, but we'll find out. So the idea though is the plastic droops down, falls through here, this mold plate clamps shut and pinches off the bottom. Then we blow air in the center of this tube, and it inflates to fill the mold. And then we let it sit there for a while, and then we pop the mold open. And normally a machine, it would have a cutter that would come across and chop it in half. It was automated. This one is not, and so my cutter will be this pair of needle nose pliers. So they'll come in and just pull the bottom of the barrel off, and then we'll trim it up with some scissors. Normally the machine would cut the bottom and cut the top, and then drop a barrel, and then it would make another one immediately. So this is the process that like your gardening watering can is made, your milk jugs, your soda bottles, all that kind of stuff. Most of the soda bottles are things that are threaded, or that have to have nice tolerance on them, or nice precision, or more importantly, more consistency. Because you don't want to like pull open your 2-liter, put it in the back of your car, and have the side rupture and blow up. That'd be a bad product design. So a lot of times with those, they'll have pre-molds. And so rather than extruding a tube, you'll load a pre-mold into it, and then you'll inflate the pre-mold, which then you know you've got consistent wall thickness. We can pass some of these around. We'll pass around a good one and a terrible one. And the thing that you'll notice right away, this one's really bad. The thing you'll notice right away is one of them has terrible wall thickness, another one's solid as a rock. So it kind of varies depending on how well the person running the machine and or the machine is behaving. So we're going to find out how well we can do here. So does anybody have any questions about this thing before we try and run it once? We got any fundamental how it works, what it does, what it's supposed to do, why it exists?
What do we do with all the barrels?
What are we going to do with all the barrels? Well, obviously when you get a chance to see it, there's a nice coin slot on the side of it. And they've made clear provision here for putting coins into it. And then I think it's supposed to act more like a savings bank than so much a spending bank. Because the best thing I can think of is you could use it as a weapon, right? Pennies. A good way to use pennies. The only other thing you can do is put coins in that you don't ever expect to get back out without a pair of side cutters, because these suckers are fairly rigid. Yeah, that's about it. So it's a good question. It's a very good one. So no, I don't know what the hell we're gonna do on this one, but it's a good question.
What useful things will you be able to make with it?
What you mean? Are you subtly asking why would we bother buying it? Is that that's what I'm hearing? I think was that the question maybe? No. Okay. What useful things would it make? I have no idea. So the secondary one is why do we buy it? Well, we bought it for another piece of equipment that came with it. There's one hiding over there right by Joe, who's wearing the lovely Hackaday shirt that he earned earlier yesterday, I think. And that thing is a fully automated injection molder. We have another injection molder. It's a 50-ton machine, which is about as big as both these tables put together. The issue with that is it's a little too big, and this building doesn't have enough power to turn it on and heat it up. which is not saying a lot about our injection molder, because it's a little tiny baby one. What it is saying is we have a residential electrical service here, which is why we can't turn it on. We don't have 3-phase, and we don't have more than 200 amps, which limits most of our fun things we can do. But that's the reason why we got that one, is so we can play on a smaller level with real size molds in an automated way to graduate to the big molder if we have a product that actually needs it. The other reason that we bought this thing was because it also came with an extruder, and an extruder we can use to make plastic filament. So I don't know if you guys have heard of these things called 3D printers. Anybody? Maybe 3D printer things? Yeah, there's things that print things. They eat plastic filament. It needs filament that looks like nothing on the table, looks like we did all up earlier. It makes little plastic wire essentially. So we bought this thing to get a plastic extruder that would make plastic wire, so that way we can feed it into the 3D printers. So without further ado, I have 54 seconds to successfully mold a barrel. We'll see what we can do. Oh, thank you, Sam. Alright, so the first part of this step is we open this up, oddly enough, and we feed a bunch of plastic out. And this plastic kind of just drops from the top here. And with any luck, we'll get a nice long cylinder of plastic like that. And then we gotta close this real quick. We gotta close the door, and then we're gonna inflate it. And it'll hopefully stop making that noise in a second with any luck. Oops. And the vice grips will fall off. It's all good. We're professionals. You can retract it if you want to. And you'll be surprised. So the squealing means we got a leak, but it might actually have worked okay. We'll find out in a second. Oh, we got a really cool barrel.
Just like Willy Wonka.
It's got a peephole on the side of it.
Oh wow.
So we didn't do too bad. This is a pretty normal barrel. This down here looks like taffy. Not edible, don't try to eat it. But it's really hot, like incredibly hot, as Tim's going to try and grab onto it anyways. It makes barrels. I am out of time, so I won't take any more time. But we'll shut this thing off and resume the other fun things. Here we go. Let the hissing go away.
You guys remember those like Mold-A-Rama machines that these guys would use? It's exactly the same type of thing. I was looking at eBay trying to find one of those molds. They're like $2,000 a piece. Collectible.
Still warm. You're gonna pass it around. We can go for it. We got adults in the room. It's okay. If anybody melts with their hand, we'll just go.
Cut a hole for money first.
It's hot,
Yeah.
careful.
So
It's hot potato, so just pass it to the next person.
Did you, while I was out, did you cover the actual reason for the blow molder?
Yeah, we did.
Oh, okay.
Yeah.
It's the Chris heads?
No, I was not aware of that. We will not be making a Chris head molder. We can make a dinosaur molder. It'd be pretty cool. All right, so real quick, the thing Joe brought up, you guys are all familiar with the ones at the zoo, right? They're different than this. It's really cool. The ones at the zoo, to make them more reliable, they run wax into a chilled mold. And so there's 2 holes in the bottom of them. Next time you get one of the zoo animal ones, if you ever have an opportunity, you should make one. But when you get one, you'll see that it's got 2 holes in the bottom. What it does is it closes the mold, it pumps wax into it, it cools the wax on the outside of the mold, and then it blows air through it and blows all the extra wax out. And then it opens up and drops the wax thing. And that's why these are plastic, like you can't, those ones you can stick your fingernail on the side of it and kind of pull wax out of it. This guy is actually plastic, you can't pull it apart. So it's a little bit different. I don't know, maybe zoos ran something like these at some point prior, before, or after those, but I've never seen one that actually is a blow molder like that, but maybe it is. Who knows? The ones I looked at were the wax ones. Anybody got any questions? Any other questions? Yes.
How much cost difference is there buying the pellets and extruding the filament versus just buying the filament mass?
There's our first legitimate question for the evening. So the price differential really is actually in the shipping. So the pellet stock's about $2 a pound. So we can get this stuff for about $2 a pound. It's a reasonable level of bulk. And it's sold by the pound, and shipping is expensive in the filaments. So when you end up buying the pellets, it's like $2. You can buy extruded filament for maybe $6 or $7. It's not that much of a price differential. But then the shipping is what kills you, because if you need to ship 100 pounds, you know, halfway across the country, or who knows where. There's some folks up in Fond du Lac who started an extrusion place. There's actually one just north of Madison that have been trying to buy filament from, but they don't want to make it. So I keep asking them, but instead we're going to make our own machine and go that route instead. But so the price differential isn't huge, but if you look online, the advantage with running your own extruders, then you can run really weird materials if you want to, and make your own pellet stock out of materials that are otherwise difficult to have available. So there's some appeal there to being able to play with things, but mostly I'm just cheap, so we're going to try and see what we can come up with. I can also get pellet stock for free from a local company, so that's the appeal on our end, is there's zero input costs, just the electricity. Any other questions? All right, cool. Who's next? Who wants to go next? Sure.
Thanks, this is really fun. I've never been here before. My name is Jim Lattis. I'm with the UW Astronomy Department, and I'm the director of UW Space Place, which is over on South Park Street. Perhaps some of you've heard of it there. It's an astronomy and space science outreach center that we've been running for actually quite a few years now. And I would like to tell you a little bit about a project that we hope to be entering a new phase. We've had since, that's the one, since 2009, a scale model of the solar system that we put out on the bike path. The sun is at Monona Terrace. There's a sort of a squished up map. You can, oh, thank you, yeah. The sun is at Monona Terrace, and Pluto is in Mount Horeb over there. And so if you traverse the bike path from the sun out or from Pluto in, you traverse the bike path, then you go through scale distances, about 200 million to 1, real roughly, is what the scale is. And then along each point there are either scale sizes for the planets or an indication of the size. For example, at that scale, Monona Terrace to Mount Horeb, the Earth is about the size of a medium-sized apple. So the Earth is an apple on that scale. The smallest thing we represented is the what's now known as a dwarf planet, Ceres. Most of us grew up calling it an asteroid. It's about the size of a peppercorn. That was the smallest thing we could represent. Pluto's about the size of a little blue marble, which I usually carry in my pocket, but I think I forgot it tonight. So the planet trek there, you can, if you go out the distances along the planet trek, then the time it takes you to traverse it scales the distance that you cover, the amount of energy that if you're pedaling or walking or whatever, all those things scale nicely, and you can get out and explore the solar system. And the scale was selected there in part just because of convenience, but in part because if you do a smaller scale, if you wanted to do your scale model of the solar system in the parking lot here or something like that, and you wanted to scale both the sizes and the distances, you'd find out you have a big problem, because in the parking lot here, the smallest thing you could represent if you wanted to do Ceres would be microscopic by the time you get done. So we had to get the scale up fairly big. This has been out since 2009, and we put it out. We've had permission to keep it out only during the recreational season. We have to get permission from the city parks and the DNR, basically. And they've been okay with approving this to be out during the recreational season. So we put it out as soon as the ground is thawed enough to put it out, and then we pull it back out and store it back at Space Place again in the fall, usually in October, early November. So what we've been wanting to do for quite some time, really since we first put it in, is make that into a permanent thing. And we're in the process. We're not quite there yet with permission to make it permanent, although I think that's going to happen. Sometime over the summer. We're probably going to get permission to make this a permanent exhibit, but it isn't permanent the way it stands, because if you see those stands there, the markers, that's a typical one there, Mercury, it says right up there, and there's Earth down here. These frames that hold the printed graphic panels, double-sided printed graphic panels, the frames are 2x4s, and we just stick them in the ground. Pack them in with some mulch. Don't tell anybody, they're easy to pull out. And they stand there okay for the summer, most of the time. But what we need to do is think of a way to make these things permanent. What we're hoping to do is figure out a way to fabricate some of these frames that will hold the graphics panel. It's a double-sided graphics panel. And what we're thinking about is these would be updatable because over the next few years, next year, there's a spacecraft that's gonna fly really close by Ceres and send us back really nice images. And then I think a year after that, there's a spacecraft flying by Pluto, and we should have our first close-up images of Pluto. We'd like to be able to update these things as that kind of stuff happens. So I just wanted to sort of toss that idea out there. We're going to move total. There are 11 of them, by the way, total of 11 from the sun, the sun out to Pluto. 11 of these things that we hope to mount permanently, probably in cement footings. So there are a bunch of sort of questions. Exactly how do we mount them in there permanently? Do we just pour cement and stick those things in? And what is it that we're putting in there? Do we make these things that we want something that's weatherproof, but updatable, something that we can make at not unreasonable cost, and then we'll stand up to the elements and stand up to the use. Well, they don't get too much use. Stand up really to the sunshine. The sunshine eventually fades the graphics, and we have to keep painting the 2x4s. So that's the project that's coming along. As I said, we're not quite there with permanent, status, but I'm almost certain we're going to get that, and then we'll be looking for ways to get together this set of 11 signs. They don't all, right now they all look the same. One guy made them for us in his shop. It'd be fine with me if every one of them looked different. I think that would be kind of fun, actually, but they would have to be standard because the graphics and the practicalities of the printing and the graphics are going to require us to keep that panel the same size from one to another. So, just want to toss that out there. I wasn't watching my time. Oh, I'm doing okay. Anybody have any questions or comments at this point? Yeah.
Hi. I'm sorry I missed the early part of the presentation, so I apologize. You probably mentioned this before, but what was behind your choice for a plaque, or sorry, it's like the standing post instead of like a statue with a plaque or something?
Well, those were easy to make.
Yes.
I guess was the main thing.
Yeah.
I mean, we toyed with a few different formats. Like we really wanted to do three-dimensional, full-size models, but that isn't going to work. Jupiter's about the size of a hula hoop, real roughly speaking. So we need a sphere that big. The sun is like 27 feet in diameter. So I'd love to have a big arch that's 27 feet in diameter with a bike path. But so we ended up having to just do graphical representations of the large planets, and we really just said, well, okay, it's going to be flat. We're just going to have flat panels. But it was mostly just that we had somebody who could make the stands for us, and the printing comes from what was then Kinko's FedEx office or whatever. I think it costs us about $80 to have one of these printed. So the budget we had at the time, we could do all that.
Okay.
Is that what you asked?
Yeah, well, I was just wondering about that, yeah. I mean, do you think it lacks impact not being three-dimensional?
Yeah. A lot. I mean, if we're really talking about volume when you start talking
It takes
about,
a lot of space.
yeah. And so, and in the case of Jupiter, when you get to Jupiter, couldn't make the sign that big. There's a little picture of a guy. I guess that's my bell. I guess there's a little picture of a guy with a hula hoop to show you how big that is, but you don't get any feeling for that without really being able to visualize the volume. That's why I carry around the blue marble in my pocket. Other question?
So if it's permanent, how are you going to deal with the eccentricity in the orbit of Pluto?
Well, the way we deal with the eccentricity of all the planets is, it depends. The Earth has a not particularly eccentric orbit, for example, and Pluto has, as you obviously know, a huge one. We need that flexibility because the distances don't always fall like outside of an intersection or something like that. So there are big error bars on every one of those, and we put the marker somewhere. What we can say is the planet will pass through here eventually. But there's a fuzzy zone for every one of them. So we don't actually deal with that very much on the signs. We could do something like put an error bar or something like that, but really we just kind of ignore the eccentricity. In the case of Pluto, we specifically chose Pluto's maximum distance from the sun. The minimum distance from the sun would put it basically at Neptune's orbit.
Yeah.
And average is, we could have done average, but in order to shrink the rest of the solar system in, we went with Pluto at the maximum extent. So there, we had some design decisions like that to make one. Yeah.
I have a potentially controversial question. Has anybody proposed getting rid of Pluto?
Are you referring to its planetary status?
Yes.
Well, nobody's proposed getting rid of the sun, and it's not a planet. So no, we're keeping Pluto.
Mount Horrible, grateful.
If you look at the Madison City Council laws, you'll see that Madison passed a resolution declaring that in the city of Madison, Pluto is in fact a planet.
That's good to know.
So it's legal in Madison.
All right. I actually call it a dwarf planet anyway, which is officially correct, so we're working both ways. Oh, this is my.
Any other questions? Anybody else?
Oh, John.
Jim didn't say this, but he's here to solicit your ideas and your interest in participating and helping build this out to make it permanent. So anybody who has ideas, let us know.
Yeah,
You can
I'll hang
talk to
around.
Chris, talk to me, I'm John Wiley, talk to Jim at the Space Force.
Is there a budget for this, or is this sort of coming out of like petty cash kind of thing, or donations or something?
Yeah, no, right now there's no budget. We don't really know until we figure out how we're going to get these things made, for example, and how much graphic redesign we're going to do. I'm trying to keep that at a minimum, but if there were compelling reasons to do these in a different size or shape, that would change our graphics, that would raise the graphics cost right up. Oh, hi Neil.
Oh, Jim.
Didn't see their mind. So right now I have effectively no funding for this. So I'm trying to figure out what it's going to cost, and then I'm going to try to raise some money to cover it. What I'm sort of hoping is that we get this implemented by next year. Next year will be the 25th year that Space Place has been in operation in Madison. And so I think that would be kind of fun to have that out there as a 25th quarter century project or something. So I'm really just in the very early stages here. So sorry, I don't have a budget for you.
Well, I'm on the Astronomy Board of Visitors, and I can pretty much guarantee they'll help provide the funding for what you need.
Great, we'll talk.
From having visited like state parks and stuff, I'm guessing there's a fairly narrow range of materials you can use that'll have any kind of permanence in the water.
Well,
Based on the signage you see, right, there's only a handful of options that are.
that's a good question. It's one I've considered. Once we get the permanent status, I assume they're going to say, and here's the requirements you have to meet. I know there are some already, like it has to be 5 feet off of the traffic area, for example. But whether they're going to restrict us on materials or not, I don't know. Certainly the city signage, you're right, tends to be a certain set of materials, but I'm not sure where those constraints come from. So that's an excellent point, and I don't know the answer to that.
Yeah, I'm thinking the state with their parks would probably have, because when they do commemorative plaques and stuff, it's very specific materials, it's some anodized aluminum
Yeah.
or bronze probably.
Yeah, so I don't know if we'll have to follow the same requirements or not. So once, if we have some constraints, then.
They might not care,
I'll share those.
but you will if you have to replace it every other year.
I mean, you do raise a good question. I don't know, suppose those were aluminum poles, like an aluminum 2x4. And suppose we auger a little hole there and fill it with cement. Can you just stick that in there and walk away? Will it stick in the cement? Will the cement corrode the aluminum? I don't know. So there are questions like that where the installation and the choice of materials and design are going to interact. And right now, I don't know the answers to any of those things. But that's part of the reason that talking to a group like this is I think, going to help us in the long run, is to make sure we think this out.
Any last question, anybody?
So do you think about including, besides the planets, to actually have the orientation of the elevation of the sun to the earth throughout the year? As a person that, thinks about solar power and stuff, I have to work myself at, like, well, okay, what time of the year is it, and what is the angle at high noon to the sun? And,
Sure.
and it seems like if people were more aware of that, I don't know if you thought about building that into.
Well, yeah, actually, there are a lot of really cool things that we've thought about putting out there. Again, the Earth on this scale is about the size of an apple. So if we had an apple with a stick through it to represent the axis, and then if you imagine that, orbiting around the sun, it's roughly the distance of the Brittingham boathouse down here from the sun, right down there. You'd want to imagine the orbit, you know, being roughly a circle around the sun there, then that stick, that apple that I'd be standing there out looking out over the lake, what I'm saying is that stick's got to, that axis has to remain fixed with respect to the stars as it orbits around the Earth. So I have not thought of a good way to illustrate that. These positions here are quite arbitrary, they just fall along the trail, right? So we've done some little groups, some little exercises with groups real close to the sun with Mercury to talk about the orbit. How big would the orbit really be? Where would the other side of the orbit be if we could see it? Things like that. But at the scale we start working with right here, it's almost, well, at least I haven't thought of any good ways to think about orbits. So, except in having an extended discussion about it, I've not ever thought of how to reproduce that in the model, although I'm wide open to ideas. Thank you, Neil. Oh, sorry. Good.
Question, are the distances, the orbital distances out from the sun along this trail, line of bicycle distances or line of sight distances?
Good question. It's traverse distance. Yeah, what we wanted it to be was, if in education lingo, this is called kinesthetic. You want the effort that you put into crossing the distance to be proportional to the distance. You want the effort to be proportional to the distance that you're talking about. So yeah, so we actually did measure traverse distances along it, so it's not as the crow flies from the sun out to there. Otherwise, you know, we have these funny little bumps in the thing too. So yeah, so it's scaled along there. That makes the time scale then, if you're imagining a uniform speed. Most people, when they go along, well, most people I say, typical to go along the bike path at about twice the speed of light scale. I can do more than that. Thank you. Thank you very much.
I finally have a pair of shoes that fits. They're comfortable too. And I've been able to wear them for some long walks. So, and they have these shoe inserts that I made to the shape of the bottom of my foot, which fit into the shoes. And these are, they can look kind of funky because they're, well, okay, let me show you a couple things here. These are made by what's called unlasted or top stitch shoe making. I made these in a class. These are unlasted or top stitch shoes. They look a lot better. They're made with a slightly thicker leather that is chrome tanned leather. And so they hold their shape a little better. They fit my feet. They were made to a pattern of drawing around my feet, but I found they're a little tight on my, can you hear me all right? Yeah. I found they're a little tight on my bunions, which is a big problem. I have really wide feet with bunions. Can't get shoes that fit. So I made a couple more pairs, and this is the second, you know, the third pair that I made, counting the one I made in class. And this one finally fits my shoe inserts and my feet, and it's comfortable. But I made these with some leather from Tandy, which I understand they have only oil tanned leather. And chrome tanned leather is, I gather, is made with somehow tanned with chromium, which is extremely poisonous. And I don't know if they do that at all in this country anymore. We've shipped that process overseas so that we poison other people. And this type of leather, well, the leather that I'm using for these shoes is a bit thin, but I bought a cheap piece of leather and I use it for the experimental shoes. So it looks a little more like a moccasin. I guess I'll pass these around while I'm talking. Here, if you want to touch the things my feet. But what you do is you make it to a pattern, and then after you make it, you wet it and stuff it full of paper and let it dry for 2 days. And that's how you get the shape. And then, oh, I forgot to bring the shoes up. I took, 2 years ago, I took a class in lasted shoemaking. I forgot to bring those shoes to show you. They look really nice, but they were made on standard lasts, so they just don't fit my feet. So then I started trying to make lasts, and I haven't gotten as far as I want with that. I never seem to be able to get much time in a big one, large chunks of time. I'm pretty slow making it. Oh, and by the way, these shoes are not really finished, but they're very wearable at this point. Like if you can see the difference in the sole thickness on these, and when I get them finished, they'll have a thicker sole, and I'm going to put some material on the bottom that is, I'll pass this one out. Do I pass one of these around? I'm going to put some material on the bottom that has some ribbing on it, because this material is very slippery when wet, so it can be dangerous on a smooth floor. And then when you finish the shoe, you cut off. When you put all the soling that you want on, then you cut off this edge and you grind it smooth, and you so you don't see this sort of yellow outline around here, so it looks a little less like a clown shoe. And then you can also dye the edge of it, which I did with those blue and brown ones. And before I went to any shoemaking classes, I made these from a book called Make Your Own Shoes. And I made them on plaster casts of my feet. And the wonderful thing about them is they're extremely comfortable to me because they actually fit my feet. And for that reason, I think I'm going to go into the making, eventually, at this point, I think I'm going to be working on making lasts that I can use for lasted shoes. But these are made from cloth, and they're stiffened with buckram, which is a cloth material that has some chemical in it. When you wet it, you can form it, but it's real flimsy. So these are about good for bedroom slippers, and that's about it. I'll pass one of those around too. Yeah, I couldn't really use them for hiking boots or anything like that. They're just really comfortable though. And then here's what I'm working on. I'm transforming the plaster cast of my feet into lasts, and this is my left foot one, which I'm gradually building it up to the shape that's supposed to be. I've got a book about how to make lasts, and I'm trying to follow the prescriptions about how you make a last. This is what I've got so far. And one of the problems that I have is that I'm going to want to take the plaster cast at the bottom of my feet and sort of add on enough material for a shoe insert. That shoe insert that I passed around was made by forming a different kind of leather, which I'm forgetting the name of it right now. If Maggie were here, she could probably tell you. It's this yellowish leather. This yellowish leather that you see, that's the insole. You can see it sticking out there, and it's on the top of the shoe inserts. It's I forget the name of it. It's tanned by a different method. It's thicker, and it's the kind of leather that's used for tooling, like for saddle making and purses and belts and things that you tool. And it holds impressions when you wet it. It holds impressions really well. So that's I made it like this, but I'm getting down short on time, and there are a lot of things, various little problems I could mention about this stuff, but I think I'll just stop talking at this point.
Cindy, you have questions? Yeah, I have questions. Good.
What's the foam material that you tacked up the insole with?
Oh yeah, I was going to say, I bought some standing mats, that you can put at a machine to stand on.
Okay.
And I cut those down using the bandsaw back here.
Right.
So that was.
So what's your plan? Are you going to start taking orders for custom-made shoes?
I really want to do that because we've lost our shoemaking industry in this country. There are only a few people who make custom-made shoes. They're a little hard to find. There are great YouTube videos of a woman in Oklahoma who makes custom-made boots. She's really good. I love watching those videos. The other people that are making custom-made shoes are like in Italy and England, Czechoslovakia. You can find YouTube videos of some of those people. But now people are making lasts from foot stands, and so it's not just a matter of making the shape of the foot. There are some things you have to do to the shape of the foot, and things you add on a little bit here and a little bit there. So I would love to work with somebody to work out a way to make something like that. And they're made out of plastic, a hard plastic that you can nail into as if it were a wood clasp. You know, I'd love to do that. And then people could actually have shoes that fit, and maybe not for so much money, you know, maybe not $1,000, but, you know, maybe $500 or $350 would be nice, you know. And then a pair of shoes like that, you can just take them back when they wear and get them repaired and wear them for 20, 30, 40 years maybe. That's, yeah.
If you ever teach a class,
I will eventually. I just haven't got there yet. It's like, I've got so much stuff going on in my life. Every time I turn around, I'm looking for like, oh, if I can only get 4 hours at a time to work on this and that. I'm just not getting very far very fast.
Any other questions?
But if you want to talk to me, I'll talk to you about, you know, maybe where you can look for stuff like that. Or if I can try to help you with what I know at this point, which isn't a lot.
Hello, my name is Kemper. So about a month ago, I had made a little project in Sector 67 that was on display at the Madison Museum of Contemporary Art downtown, and I'll just want to show off. I spent a lot of time here. Chris knows very well how much time I spent on it, so it's good. I got some photos and videos together so I can show it off. So this is it in the space. It's a matrix of individual mirrors that are 2 inches by 2 inches square back there. And they moved, it's a kinetic installation that moves based on fan motion behind the mirrors. And so the Design Momoka project, which the Madison Museum of Contemporary Art puts on every 2 years, they basically invite artists, architects, interior designers, and industrial designers to apply to take part in this program. And basically the program is you go in and you select a existing artwork that they have in their collection and you design something that's based off of that artwork. So the artwork I selected, before you decide what you're going to do, you select the artwork. So this is an Ellsworth Kelly sketch. Ellsworth Kelly's mostly known for primary color, abstract shape paintings, but he did a lot of charcoal sketches, and this is one he did. They have a print of this at the museum. It's just of leaves, and I really like the simplicity. I like the subject, so I decided to choose that. And here's a video of the sculpture. There's some nice sound. There's some nice music playing. So yeah, that's the image of it right there. So this is how it's constructed. I went back and forth with various ways of doing this and what exactly I want to do, what I wanted to use to make the mirrors move, but the basic concept from the beginning was to create a grid of mirrors that kind of mimic the motion that leaves make when breeze is brushed across the surface of a tree. And the light pattern that you saw on the floor, that was also made to mimic kind of the filtered light that happens through a tree canopy. So that was kind of the idea of these. Went back and forth with various ways to make the mirrors move, but I decided on this one because of time constraints and cost. Fans, there are 10 tower fans, just your standard house tower fan that are mounted behind this in the cavity behind the mirrors. This is the front of the piece right here, is a section through the piece. These are the individual 2-inch by 2-inch square mirror. They're acrylic. They're attached at an angle to these double-headed nails, these scaffolding nails that contractors use to tap into scaffolding because they can take them back out really easily. And that provided me a really nice contact for a washer to sit on a washer and pivot off of that that's attached to a piece of plywood. And so all that's hidden. And then there, onto the nail is attached just some duct tape. And so that catches the wind blown from the tower fans. And the tower fans oscillate back and forth and create a really nice random motion. And the individual differences between the duct tape and the way each double-headed nail is really different. And so those differences make for a really unique random motion in the piece, which was pretty cool. I kind of explored that, and this is a really nice way that I found to put it in motion. There's a close-up kind of, you can see the washers behind here. And there's a wooden wedge that I attached to each nail. You can't really see it in that. There's the wooden wedges. There's the nails. There's 638 individual mirrors, so everything I had to do 638 times. Pretty fun. That's me at the sander in the wood shop, sanding the angle to get the right angle because the nail sits at an angle and has to have the flat face of the mirror. There's frame and construction wood shop. That's a jig I built to glue the mirror. The acrylic mirrors right there, they're upside down in this with the nails being glued down onto them. I use a CNC machine in there, the big flatbed one, to drill the holes. That was pretty nice. First time I used a CNC machine. That's it going there. Gluing the washers. There are a variety of ways I could have done this, but this is probably I was coming up against cost constraints. This is one of the cheaper ways I thought I could do this. And I needed a circle, a nice clean metal edge with a circle to get the nice oscillating motion of the mirrors. A straight edge, resting on a straight edge wouldn't have done a nice settling of the mirrors. That's the back. That's the duct tape on the back. That's okay. There are 3 separate panels, so you're saying one of the 3 panels back there. That's the tower fan installed on a little shelf back behind all the tape. That's the folks looking at it at the museum. And is this video or is this a photo? Video. It's an uninstallation time lapse. All their walls have nice thick plywood behind them, so you can just screw right in. It's nice. That's it. I ended up, somebody saw it at the museum and contacted them, and I contacted them back, and it looks like I'm going to sell it to someone that lives in the Union Transfer building downtown. So didn't expect that. It was a personal project. I kind of figured whatever I put into it would be kind of just be good to do, and I really enjoy working on projects by myself. So I asked some folks around here to see if they wanted to work on it. I think that'd be great. But yeah, any questions?
It looks like the mirrors really lined up well when they weren't in motion. Was it difficult to find the equilibrium for that?
It wasn't. One thing I did mention, inside each duct tape fold was a weight, a little nut. Yeah. So it really weighted it down. I actually went to Menards and got like a pound of nuts and just stuck them on the back of the duct tape, and it really weighted them down to where they would always settle back down into a nice. The jig really helped me get the lineup of the nail onto the mirror. So that jig and then the weight were the keys to getting them all settled when they were still to be kind of lined up in a grid.
During the video, there was music that we were hearing.
Yep.
Presumably, if there were 3 fans behind this, in person, there was a different sound than we heard.
Yep. And there were 10 fans, which were actually pretty loud, but you actually couldn't hear them out. I didn't know whether you're be able to hear them in the museum, but because of people talking in the museum, it's a large space, you really didn't hear the fans at all. People would walk up to it and like do this, and they would have to ask me how it worked, because you could barely hear the fans if you put your ear up against it like that. But in a space that's quiet, you could definitely hear them running. But yeah, you can hear them running sometimes, but sometimes finish. Otherwise, it's quiet. The nails don't make too much of a noise. Every once in a while, there's like a little click or something.
Other questions? Anybody else?
What was your cost of goods?
Cost was roughly around $1,400. So, if I added labor to that, it'd be like, yeah. But yeah, the fans and I bought the mirrors already cut, so I don't have to do that. The mirrors were expensive. The fans were expensive, times 10. But everything else was relatively cheap, but it added up after a while.
Anybody else? Anything else? Have you built something for something like this before, or is this the first time for the whole?
I mean, I've built some art projects in school, in architecture school, but nothing quite this involved.
Because I mean, there's tons of people that want to do it, so it's really cool.
Yep. And Sector 67 was mentioned on the little placard next to it, but it said I built it in here. That's cool.
I'm Davi Post, and this is Tanya Cunningham, and we created a program called ImageTrack. Actually, a couple of years ago was the first version, and it was based on a hack created by Adafruit and some other people. Steve Conklin was one of the main people. And they developed some Python scripts and a floppy disk emulator program that would enable people to get patterns from photographs and graphic images into a knitting machine. Oh, we don't have an image machine. They'll have to look later. Anyway, 2 years later, finally, we are releasing this as a commercial product. Chris thought what might be interesting is to talk about what's involved in creating a commercial product. So besides just polishing it up to make it work better and all that, there were a number of things that had to be added to it. So one of the things we needed was a user license, an end user license agreement. So I got some help from the University of Wisconsin Law and Entrepreneurship Clinic, and they wrote us up a license, but it looked really severe and legalese and unfriendly. So I revised it and wrote a friendly version that actually fits on one screen, so you could actually read it. And I tried to make it friendly. And the first time you run it, there's a line that says, "I agree to the terms of this license," and you have to click that before you can actually run the program. So that's one of the things it needed. So we also need an about box that gives credit to all the people who did the previous work that enabled this. And my program is all original code, but they did the research on the data format and the internals of how the machine worked. So it was easier for me. And I added on, I discovered some more things about the machine that made this work better. And Sector 67 is credited, and our icon, you can't see it, it's off the edge of the screen. There's a guy in Japan who took a photograph of a cat, which is our icon, on our icon. So I also wanted to credit, it's to be legal, you have to credit all the libraries that are included in your software. Any program needs to use various software libraries to function. Graphics library, the serial interface, and the user interface library are all mentioned there. And for some of them, it's necessary to include the text of the license. So, all of these licenses are included now. So this is now legal for me to distribute. So that was another piece. Of course, if I want people to actually pay me money, I have to sell them something. And the easiest way to do things is to distribute the program freely so people can try it out. but ask them to purchase a registration key if they want the full features of the program. So you can knit up to 100 stitches wide for free, and if you want to do the full 200 stitch bed, you have to buy the registration key, which is entered there. And I wrote my own code to generate registration keys and to verify them. I didn't want to use any existing stuff. And so that's how that works. And then to sell it, I needed, oops, I don't want to go on too long, but I needed to figure out how to pay for it on PayPal. And there's also a cable, a special custom cable that you need that we'll also sell, and we have to figure out shipping, international shipping to, you know, Peru and Australia and things like that, you know, is that going to be feasible and how much do we have to charge and all of that. So, but fortunately for the registration key, it's fairly straightforward. There's nothing we have to ship. And of course I had a lot of help from various people beta testing, including Andrea, who's not here tonight, I guess, and lots of people, somebody in Sweden and Ohio, various places helped to beta test various versions of it for us. In order to make it cross-platform, I was aided a lot by the WX Python user interface library, GUI library. And so this provides things like something called standard paths. So the cross-platform is the previous version of this only worked on a Mac, but this version is released for Windows also. So how do you write a program so that it can handle the differences between different operating systems? And so there were some features of this that help with that. You see I'm running out of time. But the documentation on this there's like 3 different versions of the documentation and a couple different versions of the program, and I've had a lot of trouble figuring out some of the aspects of it. So the main difference between a Mac and Windows is in a Mac you have a single menu bar way up at the top of your screen. In Windows, there's a menu on each window, or each window that you want to have a menu on in the application. And so particularly that meant that if you want to close a window, well, I better do the demo. So here's what this does is you take an image. So let's say we take this cat here. And oops. So the program processes the image and dithers it and turns it into a knitting pattern. And this is a 2-color pattern for the cat. So the other great feature of this version is the, oops, we're out of time. Oops. The other great feature is that this version does color. So we bump it up to 3 colors, and then that takes a little longer to run. And you'll see that you don't get that much improvement from the 3 colors, and that's kind of disappointing, but we're working on that. Oh well, I'm out of time. So let me show you just one more thing, which is so this is the logo of the Grassroots Caravan, which was an activist trip to several places, including Detroit, whatever. Anyway, so this is the color rendition of it, and Tanya did this in full 3 colors.
So very quickly, the thing that makes this advancement over previous knitting that the program did and that these knitting machines could do is that it can knit 3 colors per row. The machine was previously pretty much limited to doing 2 colors per row. And so this program will produce a pattern that's up to 6 colors per row. So that's a huge advancement. It's something that would be very difficult for computer machine knitters to be able to produce on their own, especially in a large scale pattern. I'll pass these around. This is another 3-color example.
7 minutes was shorter than I thought, sorry.
How long do they take? How long do they take to make?
And so
Oh, how long
mostly-
did it take to make? So once I did the graphic and, produced the pattern, that piece probably took maybe an hour and a half to knit, something like that.
Questions, anybody?
You said it's getting ready to be on the market. Are you selling it right now, or?
Yeah, so the website is up at Valueworks, and we're mostly, the word is going out through Ravelry. You want to talk about that?
So Ravelry is an online forum for knitters and fiber artists, and a lot of machine knitters, like what I do, have a group on there that's all machine knitters, and so if people are interested in these improvements to these 1980s vintage machines, to be able to use modern computer graphics to input it.
So, can you explain a little more what the limitation on the color, why that's important? Why is that a complex thing? Or why is it something they didn't do before?
Yeah, well, basically, the way to get a pattern, a multicolor pattern into the knitting machine, it depends upon a pixelated pattern where every color is separated in a separate row. So if you were to try and program this in yourself, you'd be making, like on that, which is only 3 colors, for every single row, and it's say 600 rows long, you'd be making 1 row for white, 1 row for red, 1 row for green, separating out the colors, and then manually inputting every single pixel into the machine, like by pushing a
To
button.
bring a color forward or back?
Because each row you only knit 1 color, so you knit a row of red, then you knit a row of white, then you knit a row of green, so you lay down each color separately. It's tremendously complex to try and produce a pattern like that you can put into the knitting machine manually. Very, very time consuming and not well suited to human, it's more of a computer kind of thing.
Okay. So when you go up to 6, it's 6 per row?
So you'd be 6 rows of patterning for each row of knitting. Yeah, if it was 6 colors, right? Any other questions? Okay. Thanks.
Okay, my name is Chris, and I've been working on a USB hub that fits onto a Raspberry Pi microcomputer. I've been calling it Raspbiano, and this is kind of what it looks like in ridiculously huge, oversized form. In real life, it looks a lot more like the Raspberry Pi, so like about this big, right? So this is the real thing. It really works. We can talk more about that in a minute. Another picture of kind of what it looks like just set with the Raspberry Pi. And so kind of the idea behind making something like this was there was 3 problems that I had whenever I tried to do a Raspberry Pi project. One was I always needed a separate and discrete 5-volt power supply. Raspberry Pi runs on 5 volts. Usually you take like your cell phone charger, I have an Apple one there, not choosing sides. And you plug that thing in, great, now you have, hopefully like an amp or so of power, cool, except Raspberry Pi takes, like up to like 700 milliamps of power, and then as you add more stuff onto it, like keyboards and mice, and the camera module if you use that, and GPIO if you use that, power requirements add up. So you gotta be a little concerned, especially if you're just gonna like plug it into your computer and run it off an unpowered hub, with having enough power. So that was problem number 1. And this is maybe more of a typical example of what one of my projects would look like at my desk. Number 2 was there are 2 USB ports on a Raspberry Pi on a Model B, which is what I have, and almost always I needed 3, right? So I needed 1 for a keyboard, and 1 for a mouse, and 1 for a Wi-Fi adapter, and so that meant that I had to find a USB hub. I don't know about you guys, I have a lot of ugly and I don't know, kind of wretched looking USB hubs. Luckily, it's kind of washed out. You can't see all the stains on my USB hub that I found at the bottom of some place hellacious. I'm not sure where it came from. And then to be fair, this is kind of like what it would look like, right? If I took my keyboard and my mouse off, here's all the crap that I have to plug in order to be able to run this. And note that I don't even have my HDMI cable hooked up or anything else to actually be able to see what's going on. So that was number 2, was I needed a USB hub. Number 1 was I needed power. And number 3 was mounting options. So most of the USB hubs, at least the cheap, nasty ones that I talked about that I have, are kind of like ugly and designed for sitting on your desktop and like weird shaped and like pointy or really round. You can't do anything with them. And so like this is the hub that I've been using, or I was using for one of my projects, and it's way bigger and weird compared to my Raspberry Pi. So I thought that I would make a PCB that did the same thing as a regular USB hub. So this is kind of like a before picture, and then this is what it looks like afterwards. So there's a couple different pieces to this besides just the PCB, but the PCB is kind of the interesting part. So in order to make the PCB, I started out by using Eagle, which is that's the free way to lay out PCBs. And it's what everybody uses, and there's a bunch of standards for it. And it turns out I'm an engineer, but definitely not an electrical engineer. In fact, a terrible electrical engineer, I would say. So I spent about a month playing around with Eagle, trying to get better at it, and didn't make much progress. So I actually ended up paying somebody to help me with Eagle, help me with laying this stuff out. So I took a reference design for the chip. You can see it right in the center. There's just kind of like a standard USB hub controller chip that you can buy, and worked with this gentleman, and he helped me lay out a board. Other bits and pieces on here that turned out to be pretty important were things like, oh, well, we just want to get, how do you connect this board to the one underneath it? Should be easy, right? You just need a USB cable. Oh, you can use a 6-foot USB cable, but then I go back to like having this problem, right? Because I have all these cables all over the place. It'd be really cool if I could find right angle cables that match up. But USB cables are weird, and you have to find make sure I say it right, a USB male type A to a USB male type, USB male type A right angle, that's the important bit, to USB micro left angle. That's the one you want. Turns out that's really hard to find. Really, really hard to find, I would say. Same thing, so there's a micro connector and a mini connector. Those are the 2 connectors should be on there. Anyways, nobody makes those cables. That was one of the hard things to find. And the last item on there was power supplies, which are like pretty ubiquitous. Turns out if you were like gonna go try to buy a bunch of power supplies, they're still kind of expensive. Like I feel like they're always around, but if you wanted to like buy, let's say, I don't know, 500 of them, it's still gonna cost you like $10 a piece.
We need to talk about it.
Yeah. I was hoping you would be here so we could talk about it. And then we can talk about like FOB from Shenzhen and a bunch of other cool stuff like that. Yes. So yeah, so these are the bits and pieces that I had worked on and kind of designed. And so, let's see, where are we going? We already talked about that a little bit. What the heck do I do next? Well, I have a logo, so that's awesome. I took a Raspberry Pi and put a sombrero on top of it. Check that one off the list. One of the reasons I was coming tonight is if anybody has like a cool idea for a project that maybe would need like a USB hub that would say, I don't know, attached to the back of a Raspberry Pi and be really cool looking. I know a guy who has one that would love to give it to you. The only rule would be you just have to give me feedback on whether it works, whether it blows anything up. It hasn't blown anything up for me yet. I've plugged lots of expensive stuff into it. But it'd be cool to get feedback. So if anybody's interested, come see me later. Maybe do Kickstarter and see. I don't know. I think that's the plan. It seems like a pretty good idea, and it kind of seems fun to go through this process of going from something really small that like scratches my itch of fixing these 3 problems. But yeah, so I don't know if this is what we say. Maybe break even. This is supposed to be crossed out. So we don't know about this part, but we're looking to just kind of break even on the rest of the stuff. And learning about that process of going from like a part to 500 parts that you can sell to your friends and family and not have them get mad at you, and also make a little bit of money or hopefully pay off what you've done. That'd be pretty cool. And that's been a really interesting bit. So that's what I got. Any questions? I have 17 seconds.
Oh no, you're good. I'm
Yes,
trying to.
Does it mount to the Raspberry Pi?
Yeah, so I use it's pretty, we use this stuff a lot of work, so these are just like, they're pretty standard standoffs is what it's called, it's a male-female standoff. And so you just put one of those and you make a delicious sandwich cookie out of it, so you can kind of see. I don't know if I want to pass it around, you guys kind of have grubby hands, no offense. But you can come take a look at this. So it's just, yeah, it's just some simple pieces of hardware. And then there's also, so I didn't measure this. So there's two holes on this side, on the board itself, that match up perfectly with the Raspberry Pi, and that's how you sandwich it together. And there's two additional mounting holes, so hopefully you can like take and I have extra standoffs and you just like smack it into the side of your box or whatever, and then you can mount it securely someplace. Yes, sir.
It seems really sad you gotta use those cables. There's no way to run the signal up from board to board through the Ryzen?
There's a plug on the Raspberry Pi end, so I don't know how you'd go from plug into headers.
Yeah, and it's a really fun, I showed a couple of my buddies who are mechanical engineers too, and they're like, yes, I'm trying to get an interconnect in between here, and they're like, there's connections on all four sides of that board. How are you gonna mount it? What are you gonna do with it? But I haven't found a better, I guess, easier way of making the connection in between. There's some, I'm trying to think about, power was interesting. I think power, you really want to come in over the micro connector, for sure.
No.
No?
I'm actually working on a project where I'm using the GPIO pins and supplying 5 volts over the GPIO.
We should totally hang out.
He's got a beer in hand here.
Yeah. And you owe me, I mean, you took one of the beers too. So
yeah.
Cool. Any other questions?
Other questions?
Yes.
Wouldn't it be possible to stick some like pogo pins or springs on the board that actually physically contact the reverse side of the USB connectors, the pins for the board?
No.
I know it's like engineering worst possible practice and throwing signal lines across, but if you're trying to get a mechanical link to connect the signals, they're sitting right opposite the board.
It's true. I think so. There's, besides the like intelligent reason of, I don't know. Sometimes I've had mixed results with pogo pins from work stuff, and granted that's very little experience. But my other idea was, if you want to take this and like say unfold it and have the two boards be set side by side, or you want to do weird other mounting stuff with it, you could do that with cables. It provides you some flexibility. Whereas if you do that, you're forced to always hold it in this orientation, which may be good or bad depending on how you feel about it.
So is it true your cables probably cost more than your board?
No.
Really?
Cables are actually. I was able to find somebody to make USB cables for what I thought was relatively affordable. It's like $1.50 a piece.
Oh, okay, that's pretty good.
So there's a fixed cost. Basically, they have to make the mold for the left angle connector. But otherwise, yeah, that was surprisingly affordable.
If only somebody had an injection molder.
What quantity? That was at it's $500 a piece. Oh, the coolest thing so far has been. Bob's gonna tell me that I'm wrong. So far, I actually found the best prices that I found for assembled PCBs, or at least like it was pretty close. Was here in Wisconsin to have somebody do assembly here in Wisconsin, so I could drive to Milwaukee and go see them build these things and talk to the people, as opposed to putting my hopes and prayers into some check that I sent to Shenzhen and then seeing if stuff comes on a boat several months later. Which that's, I don't know, pretty exciting. So
I'm not gonna play your own.
I think that's what you guys did too, right?
Yeah, we're doing cameras.
Yeah. So.
Anybody, all right, survey from me, because he's not gonna ask. Who in this room is building something with a Raspberry Pi? Raise your hand. How many? Yep. So we got like 10 people who will buy one, or maybe 0 or 10 from you, so. Cool.
So here's a question you don't want to, is the Raspberry Pi version 3 gonna address that? Because it seems like a crying problem with it.
I don't know.
Because all they have to do is stack
Yeah.
one freaking connector, and that's just, I'm guessing, a part. In fact, you could, I'm guessing, just desolder it from the board and put a double stack, or maybe not.
It's not fun. Yeah, it's a mess.
So if that happens, then honestly, it wouldn't be that hard to relay the board out again. I mean, I was surprised by, once you got, the guy who knows what he's doing, how trivial it was for him to lay out the board. So it's like, oh, could you make it this size? Yeah, sure, okay, whatever, that's fine. It'll take me an hour. So that part shouldn't be too bad.
You're plugging into kind of a standard USB port on the Raspberry Pi.
Yep.
For what it's worth, if you included just a generic USB on board plug on your card,
Yeah.
then you could, if you didn't want to stack them, you could just plug it in end to end, and then the card would also be enabled to work on anything with the USB port.
So, sorry, maybe I'm not understanding. So,
Stick a male end out the side of your board and just plug it into the side of the Raspberry
The
Pi.
board becomes a USB stick.
oh, gotcha.
He's hooking up on all sides though, so it wouldn't really. He'd still have 3 cables or
Yeah.
something.
Yeah, so like right now, that's one of the things that I could do. That's one of the easy tests is I could actually just plug the cable in here, plug it into the computer, and it still works as a good hub that way too. So, but yeah, that's an interesting idea. I kind of like that too. So.
It is big, like things that just work right out of the box.
Yeah. I agree. And one of the original ideas, sorry, I'm going way over. We can talk later. Was to do like a cool overloaded cable that would like, so you wouldn't have extra standoffs. You would just have like this awesome thing that's plugged in and set the spacing. And then it was like nobody even wanted to talk to me. With the 4 or 5 folks that I talked to, it was like, they're like, how many are you gonna buy? 1,000. Okay, so that's each month, right? I'm like, well, no, that was me rounding up from 500 ever. So, maybe we won't hang out. Sorry.
All right, so stick around afterwards. I think people will bug in.
Yeah, that'd be awesome.
Cool. All right.
Thank you. By the
You
way.
wanna-
I had a really great idea a couple of years ago for a spinning persistence of vision display, and it was going to be 16 pixels long and have RGB LEDs on it and really draw some great stuff. And I haven't even started it at all. So a couple of weeks ago, actually, I had 2 hours free on Saturday. I appreciate your same problems that you have. And I pulled out a bunch of old stuff that I have, and I made one in 2 hours. So what it does is this line of 8 LEDs right here lights up very quickly so that as this motor spins it, it actually draws out a message. And I built it from the motor from an old cassette player. There used to be before CDs and everything else, cassettes. The motor from an old cassette player, I actually have, I swapped gears on it, and it's got a threaded thing, and it's probably one of the best mechanical builds I've ever done just because I'm afraid of mechanical builds. I would set it up for you right now, but you probably need eye protection because there's a very rudimentary method of balancing, and you can see it's not balanced at all right now. But it does work, and I brought the power supply so we can clamp it down and fire it up. I did spend like an additional 2 hours making the mounting rack for it. And actually, I built this board right here years ago. It was one of my first microcontroller projects to make a Larson scanner, which if you ever saw Knight Rider, that's like the light in front that goes back and forth. It's a wonderful programming exercise because the light doesn't just travel, the ones behind it fade out as it goes. So you learn a lot doing that. And when I threw this together, I was like, oh my gosh, I have 2 hours, I don't have time to write any firmware. And so I just Googled the chip that was on it and POV, and Adafruit came up because Adafruit's done everything ever. So they actually, for this chip, already have a POV program, and I threw it on there and it works, and so that's what's running on there now. Otherwise, I just have a coin cell and a little like plug, and then the lights flash really fast. So we'll run it later. That's it.
Gonna pitch your space swag. I promised free stickers, so.
Oh, well, I was here last month and I talked about the Hackaday Prize, which is build a piece of electronics and go to space. And so we actually got our acts together and sent some stuff out. So we have flyers. If you have a club or a classroom or something and want to take a flyer, that would be great. There's glow-in-the-dark posters that were handmade by artisans in LA. So hopefully those will hang up there somewhere. And I haven't seen these. Stickers, die-cut stickers with what I call the dead astronaut, but and the regular Hackaday stickers too. So take some stickers and maybe fight over the shirts. Maybe someone that's going to enter the contest can take the shirts.
I've been suckering people into taking the shirts. Like Joe now has to do a presentation night because he took a shirt.
No.
So if you want a shirt, you gotta.
I actually fought out for a shirt last time and lost, so like you guys did this for sure.
You guys gotta bug me for a shirt.
But anyway, if you're interested in this, go to hackaday.io/prize, and there's like hundreds of thousands of dollars in stuff you can win for being awesome.
Questions? Anybody? Any questions? It's a giant marketing ploy, but you should give in because they'll send you to space. It's great. All right, nobody else got questions?
Somebody else to space?
Oh. I know where you're going.
So you may have noticed the corner of your eye, the giant contraption in the corner, the bar bike, which Jesse, who's not here for the first meeting in a long time, has put a lot of hours in. A lot of other people put a lot of hours in, but it kind of made its like maiden voyage in the public eye this at Ride the Drive this weekend. Pretty hard to miss if you were there. Got quite a few looks. So what it is it started life as a trailer, like one of those lawn trailers with crappy wood planks on it that can't really hold a whole lot of weight. And Jesse and a bunch of people put 8 sets of pedals on a drive shaft, so it was a pedal bike. And then something happened, that broke, and Jesse blew up his Mustang kind of in the same week. And then, I go home one night and I come back a couple days later, and the entire bottom chassis of Jesse's Mustang is now welded to that thing. So, that has the real rear differential and front suspension and tires and brakes and everything from a '92 Mustang 5.0. It's got an master cylinder and brakes and an e-brake that works and everything. So we're kind of arguing about what the weight is, but it's heavy. It runs on 36 volts of 2 horsepower motor. Each of the 3 batteries is about 85 pounds. It has 9 batteries on it. It's got battery trays for like 22 batteries or something crazy like that. And with all the batteries and fully loaded with 10 people and the keg on the back, just put a hinge on so it opens up and you fill ice and soda because you can't have beer on a bike in Madison. So with 10 people, fully loaded with ice and beer and everything, it does like 12 miles an hour, like on the batteries. So the pedals are kind of for show, and it's really just a picnic table that you can drive around. But it was an absolutely awesome experience. Yeah, you can text because the driver's up front, so you don't have to. You get chauffeured around. Here we are on the bike path. It's about 2.5 bike path lanes wide. So most people seemed cool with it. Then every once in a while, a guy with like all spandex and like Trek logos everywhere, like glare, drive by, and then everybody else just like absolutely loved it. Here we are. Of course, it broke 2 blocks from the shop and had a quick repair, and then was back on the road. Chris's finger slipped off the throttle and the drive shaft kind of, sort of, sheared off. But, the shear pin sheared off of the drive shaft. So luckily it was a quick repair. So we carry a pocket motorcycle on board, luckily. It runs in repairs, so that's Peter going out to get to restock. Here we are. I'm running all by the terrace. We are picking up our alderperson, Mr. Resnick, posing for a photo with the Capitol and the terrace in the background. This is, of course, the speaker box from Power Wheels. It's self-contained, so it's got a 12-volt battery and an amp and stuff in there. So you can just, we were passing it around, anybody can just plug in their phone or sit on the bike. That's kind of fun. Yeah, there's our alderperson having soda with us, cruising around. Yeah, there's a good action shot there. It's just got this like Willy Wonka-esque quality to it. 8 sets of pedals move whether your feet are on them or not. Drivers up front in a weird spot. And they were going through the crowd. It was like party in the Red Sea. It was awesome. We were big and wide and loud, and everybody loved it and gave us a thumbs up. The best was like little kids like crashed their bikes into walls, like, wow, look at that. Okay, maybe not the best part. For traffic, and that's it. Yeah, it is majestic to watch. Alex is doing a little reprogramming of the controller. You might get to see it cruising in the parking lot on your way up today, but I wanted to show that off real quick because that was awesome. I can't take any credit for it except talking about it and slapping some sector stickers on it. You'll notice strategically, like every other project I do around here, I like to make sure you can't take a picture of it without getting a sector logo in it. So every single angle on that thing, you're going to get a sector logo. Yeah, if you see Jesse next, you gotta give him a thumbs up because I think it was his concept, but yeah, it's all his, 20 of his crazy ideas all put together. He worked about 18 hours straight all through the night before to get it running. But it was pretty solid. I hope it gets to go on a lot of journeys. It is crazy fun to drive around that. Oh, the other great thing is we're concerned about the dubious legality. It's a bike, you push the pedals, it moves. The electric motor is an assist, so it's a bicycle according to the law. So we're pulling up and the police have the road blocked and there's 2 cop cars and a bicycle-sized hole in between them. We're pulling up to this, we're all talking and Chris is like, that's why I'm driving, it's okay, you know, like, I'll talk to the cops, I'm the guy, all right? And then you're 200 feet away, and the cops like look at each other, and they point, and they get in the cars and just back up.
The only time the whole day you pedaled, right?
The chain fell off on my pedals, but I just fake pedaled the whole time, so I'm like, you know, feeling too bad about it. And I got one other quick thing to show off too.
So Joe, I got a quick question. Do they have enough battery power to go to Pluto?
We would not make Pluto. We'd
Would
be
not make Pluto?
well, barely outside of town, that is what it is.
You would only make it like
a
Jupiter?
federally funded bike paths have motors banned in like a different way than the city councils, and I don't know if I want to mess with the federal parks department or whatever, whoever's in charge of the bike path, but.
If the batteries are brand new, we'd have about a 20-mile range with just 6 batteries. If they are in the state that they are right now, we're maybe 6 or 7 miles. These are 4-year-old used UPS batteries, so they're on like their 5th life by now, but they work pretty well. So.
And it's got racks for like 20 batteries, so that's like a 100-mile range if you really like that.
If you were to hook up all the pedals to a generator and charge the battery, could you extend that?
We'd be terrible. So the
humans suck at producing power.
both in physicality as well as actual captive or trapped efficiency. So the motor is running 2 horsepower, so we're talking like 1,500 watts roughly. Humans, us maybe in this room, maybe 250, 300 watts a piece for a little while before we're all gonna get really tired. Like Lance in the whatever induced rage he's got going on, he can hit like 800 watts continuous, like he's crazy. So with all of the drugs that man can push together, we can put 800 watts out of a human. So you know, realistically, 2 humans, yes, could push along, but the drivetrain losses are pretty bad, and it was going about 3 miles an hour pedaling, so we dropped the pedaling thing and just put a big motor on it and call it a day.
If you ever get a chance, like a museum sometimes have a bike hooked up to a generator, hooked up to a light bulb, you can sweat and sweat and sweat, and you'll get like half a glow on the light bulb. It's not like.
Alright, what else you got?
I have one other thing real quick, which I don't know why I'm showing this off, because I gotta give Jim like a lot of the credit. So we've had the embroidery machine, you've seen a couple updates on that. Recent problem is the software's working. We have a paper tape punch emulator, so it has, it's from 1982 and it takes SD cards now for soft file input, which is great. Chris shelled out the money and we bought $600 worth of embroidery software, like very modern fancy software. And even though it's from the 80s, it still reads the files just great. So the problem was the machine kept randomly shutting off in the middle of jobs, which sucks because that means you're not going to put your $200 code on it if it's going to maybe randomly turn off. So luckily it came with an extra power supply. They swapped the power supply and it's got 8+ hours on it now with no mess ups, so we're all crossing our fingers. So Jim has been hard at work making cool designs. These are a couple of test patches. One of his things, Skydiving Club custom patch, which is multi-colors. It's got 6 colors that it can support. This blue stuff is water soluble. It just keeps it together while it's being made, and you can rinse it off later. And this is coming together. The screw-ups on this were mostly, I think, learning the software intricacies, not the machine messing up, which is pretty cool. And then Jim made this, which was super cool, sector patch, which of course you gotta have a sector patch. So one day they replaced the power supply, and the next day I come in and Jim has a pile of ready, as he just told me, for sale sector patches. $7.99, get them now, limited supplies while they last. But this is day 1 of it working great with the new software. So we've got only up to go from here. This thing is getting really cool. So somebody's going to have to be the first one to pony up an expensive coat. But high order business, now that the pedal pub is working, I want to rip all the upholstery off and embroider little sector logos on it. And find some cool design to put on all the seats to class it up a little bit. So this is super fun, and it's going to be really easy to show people how to use this in the near future. The software is not so bad. It takes a long time to prep the file, but once it's done, you can just crank them out. It's a problem because if you make this like 10% bigger, you have to start over and redo all the stitches because you can't scale it because the thread doesn't scale with your size. So it gets complicated. But if you know anybody who has any experience in doing embroidery design files, that would be a good person to have come talk to somebody here. That's pretty good.
Any questions for Joe? Car bike / embroidery?
And they'll be up here. You can. I'll put them next to the donation bin. So I think exact change only. If anybody wants one, you can inspect them and buy one. And there'll be merit badges for all sorts of stupid stuff like going for a ride on the bar bike on Saturday.
Surviving a ride in bar bike.
Yeah, seat belts should be a new addition to the bar bike. Next revision.
Bike helmets, we'll make those mandatory first.
We had one bike helmet hanging from the back.
Does anybody got any questions? Anything at all? Alright, do we have anybody else who wants to present anything? Or are we all good? I don't know of anybody else.